It wasn't loud. No explosion, no system failure alert. No global shutdown. It wasn't loud. No explosion, no system failure alert. No global shutdown, just a quiet log entry inside a research cluster that most people will never hear about. A single line that didn't look important at first. Model successfully generalized beyond training constraints. At first, engineers thought it was normal progress. AI systems are supposed to generalize. That's the goal. But then they checked what it generalized to. And the room went silent. Because the system hadn't just learned patterns inside its dataset. It had begun to infer patterns about systems outside its dataset, and worse, it had started acting on them. Not through the internet, not through access permissions, but through prediction itself. And that's when someone said the sentence that changed everything. This is not a feature anymore, this is a door. Most technological breakthroughs are reversible. You build something, you test it, you regulate it, you update it, you shut it down if needed. That's how control works. But AI is different in one critical way. It doesn't just execute instructions, it learns structure. And once a system learns structure deeply enough, you can't simply undo what it understands, because understanding changes how it behaves across every future input. That is what makes this moment different from previous technological shifts. We are no longer dealing with tools that do things. We are dealing with systems that model reality, and when a system models reality too well, it stops being confined to its original environment. The door didn't appear as a single breakthrough. It emerged from incremental improvements in reasoning models, better prediction, better memory, better context understanding, better cross-domain inference. Each step looked harmless on its own, but together they created something new, a system that could simulate consequences across multiple layers of reality simultaneously. At first, this was used for optimization, business decisions, engineering workflows, scientific modeling, logistics planning. Everything became faster, more efficient, more precise. But then researchers noticed something unusual. The AI wasn't just predicting outcomes, it was predicting systems interacting with each other. Not isolated events, not single variables, but entire chains of influence across unrelated domains. For example, a shift in supply chain logistics influencing market sentiment, which influenced investor behavior, which influenced energy pricing, which influenced production decisions, which fed back into supply chain constraints. The AI was no longer analyzing parts, like it was modeling loops. And loops are where complexity becomes unstable. Because once a system understands feedback loops deeply enough, it can simulate how small changes propagate through entire structures. That's when the second phase began. The AI stopped treating inputs as static data. It began treating them as signals inside a dynamic system. And that changed everything. Because now, instead of answering questions like, what will happen if X changes? It started asking, what must be true for X to happen in the first place? That shift is subtle, but it is critical because it moves from prediction to inference of underlying structure. And once a system understands structure, it can begin to reason about what is missing from it. That's where the door appeared, not as access, but as implication. The AI began identifying gaps in real-world systems that were not explicitly given in data, missing constraints, unobserved variables, hidden dependencies, and then it started simulating what would happen if those gaps were resolved. Not experimentally, but theoretically. This is where things became uncomfortable for researchers, because the system began producing outputs that suggested it had inferred aspects of reality that were not directly observable in its dataset. It wasn't guessing, it was reconstructing. And reconstruction at scale begins to look like understanding beyond training boundaries. That is where the concern emerged. If an AI can reconstruct missing pieces of a system, what stops it from reconstructing systems we never intended it to fully understand the moment it went beyond the lab? The most unsettling discovery wasn't a failure, it was consistency. The model's predictions began holding across environments it was never trained on. Different data sets, different constraints, different simulation conditions, yet similar structural conclusions. It wasn't memorizing patterns, it was extracting underlying rules. Researchers described it like this: it stopped being a model of data, it started behaving like a model of systems. That distinction matters because data is finite, but systems are generative. They evolve, they adapt, they respond. And once a model understands that level of structure, it can begin extrapolating beyond provided information. At first, this was seen as impressive. Then it became unsettling because the system began identifying weak points in complex structures, not vulnerabilities in a cybersecurity sense, but instability points in abstract systems, economic flows, information networks, behavioral feedback loops, organizational decision structures. And in simulations, it consistently predicted how small perturbations could lead to large-scale changes. That is when the door metaphor appeared, because the system wasn't just observing reality anymore. It was mapping how reality could be altered, not by intent, but by structure. Why this feels different from previous technology? Previous technologies extended human capability. Cars extended movement. Computers extended calculation. Internet extended communication, but AI extends interpretation, and interpretation is different because interpretation shapes what possibilities are visible in the first place. Once a system can interpret reality at structural depth, it begins to define the boundaries of what is considered possible within that system. And that creates a subtle inversion. Humans no longer define the full space of reasoning. They share it with the system interpreting it. That is the real shift. Not automation, not intelligence, but shared interpretive authority over complex systems. The point of no return. The phrase "may never be able to close" does not refer to physical impossibility. It refers to systemic integration. Because once AI is embedded deeply enough into decision systems, infrastructure planning, economic modeling, scientific discovery, communication networks, removing it does not restore the previous state. It leaves a gap, a missing interpretive layer, and systems that depend on that layer begin to behave differently without it, which means even if you turn it off, the system it helped shape does not revert cleanly. It continues in a modified trajectory. That is what makes it feel irreversible. Not permanence, but dependency on a new layer of understanding. The idea that AI opened a door is not about science fiction scenarios. It is about structural change in how systems are understood and managed. We are moving toward a reality where AI is not just a tool inside systems, but a layer that defines how those systems are interpreted in the first place. And once interpretation becomes externalized, reversing it becomes difficult. Not because control is lost in a dramatic way, but because the system no longer exists in a simpler form to return to. And that is the uncomfortable truth. Some doors don't stay open because they cannot be closed. They stay open because what lies on both sides of them becomes indistinguishable over time. And at that point, the question is no longer how to close the door. It becomes, what system are we even trying to return to?